This is the first video lecture that I want to talk to you about. Sort of looking at the PowerPoint, I want to go directly to the book for this is chapter 1A in the Farrell book with it. So let me just walk you through how to study for computer science with it. Now, some of the stuff I'm about to advise you, what works for me doesn't necessarily work for you. But for the most part, all I could tell you what works for me is you could try it on your way, the way how you want to study computer science with it. But for me, when I read things, I have to read things three times, several times with it. This is a technical document, so you can't read it one time and expect to absorb this. If you do, you must walk on water. The second point I want to make is that when you the second point, how you want to study computer science is you got to read. The material is not hard. What's hard about this material is the amount of the material. All right. So there's nothing that you can cram in like an hour, 2 hours before an exam and go and take the exam with it. I mean, it's going to take time to absorb. So I recommend you reading this stuff 3 times. Seems like for me is a good number. And I always like to learn kinesthetically, so I write out definition of words and I make note cards. Things that are repertoire for me. It just helps with it as well. All right, let me get into this chapter right now. What I'm about to do is talk to you about how you can see frequently I flag this so I can know how long I'm going with this right now with it. So read all the chapter objectives with it. I'm not going to read the chapters for you, but I can guarantee you words that you see for the first time you read, understand computer component and operation. This is the subheading that talks about the details of each of the sections with it. You think you know what hardware is, you think you know what software is. Again, these are just definition words. Anything that is bold is fair game. So one of the test questions I wrote for example, I'll read you an actual test question for software, for example, here. So the test question I could ask for software could be something along the line with, excuse me, my computer just pooped out on me. There we go. Computer programmer, also known as blank. Choice A, data, B, hardware, C, software, D, information. As you can see, software is a computer instruction. Software tells the hardware what to do. So you got to know the definition, the word and its definition, and you got to know the definition that attaches to the word. So note cards come in a good hand that how you study each one of these things with it. So know all the bold words that I have here: input, process, and output, application software, system software. All these things are all viable communication in our computer science world with it as well. Programming language. I want to talk to you about pseudocode and different type of code. One of the first thing is that you're going to hear me talk about flowcharts and pseudocodes and algorithms and all this stuff with it. Ultimately, you're going to write the source code with it. So the source code in here is what you're going to be writing in this class is the C++ using a Visual Studio editor, the C++ editor that I had you download for the first lab with it. Now, when you write your first code, your hello world, you follow exactly what I did. You shouldn't have any problem, but there are 3 types of errors that could arise when you write programming with it. The first time you write code, you're going to run across what's called syntax errors. Syntax are just simple punctuation, misspelling of words. They're just getting used to the language vocabulary at the moment with it. You're going to come across what's called semantic errors as well. What the compiler does is basically it's a compiler. You hear what the term compiler or interpreter. It basically comes down to it translates your higher level programming language to lower level programming language to the RAM memory with it. So read through this, you run it, you execute it. This is the basic logic of the code. So the second type of error you can get from compiling a code, which the compiler has no fault at this, it's just logical errors with it. So logical errors are errors that from the human being that we tell the computer to do, It's doing exactly what we're doing, telling it to do, and it's still giving us the wrong output or whatever the instruction may be. So that's a logical error. Third error is not mentioned in here. It's called runtime error. We'll talk more about that later on when we get a chance to do it. One of the things I want to talk to you about is memory. Three types of memories. The first type of memory is the BIOS. That's firmware. Also, you're familiar with that. That's not mentioned in here. The second type of memory is your storage. That's on your C drive with it. So anything you write to a USB external drive, things like this, or a hard drive, you turn off your computer, you come back, it's still there. The third type of memory, which is very, very important in our business, is what's called a memory. Random memory access memory, random access memory in this. It's RAM. So in the RAM memory, anytime you turn off the computer, meaning no electrons circulating in the chipset with it, it basically wipes everything off. And the term you need to know for this course and the next course is called volatile. So volatile means that anytime when you have a particular RAM memory that you want to turn off, it just goes away. The entire memory goes away with it, which is a good thing. I'm telling you, it's not a bad thing. So a lot of times if you overload a lot of your random access memory, you want to clear it. So what do? You shut it down in your computer and you turn it back up with it. 99.9% of the time, it should work back to the way how it's supposed to work with it. So, all right, I'd like for you to know understand the programming process with it. There are several steps in here, 7 to be exact. So it's understanding the problem, planning the logic of the problem, coding the problem, using the software with it, testing stuff. We're actually going to follow these 7 steps through this entire first 3 chapters of the book with it. So a lot of this stuff is going to be repertoire, but I would know the 7 steps cold with it, take it step by step with it. So when I talk to you about how to break down a flow chart and algorithm, we're going to basically follow through these 7 steps with it as well. Really nice depiction of how this is used as a flow, kind of like a circular. In industry, this is very similar to what's called the spiral model that we use with it, but here they call it the program development cycle with it as well. Please know this. Read up on this. It's pretty self-explanatory. I'm just brief it with you. You got to understand the problem. I mean, it's very hard to program something when you don't understand the problem. Let's take something for example. Everybody knows how to balance a checkbook, right? If I gave you a ledger book, pencil, paper, and a calculator, you know where the balance is. You subtract what you paid for. If you have a paycheck, you deposit. It goes on which column. That's logic. That is programming logic with it. There's nothing that I can tell you that's any different. But when you program something, what has to work on paper first before you feed it through the machine? And that is huge because you can't expect to program something, to problem solve something, when the process is not there, when the logic is not there with it as well. Okay? So please review this on your own with it. Each of the things that we need to talk about with it. I want to talk to you about what's called an algorithm. Okay, hold on a second. Let me check the time here before I don't want to go with this. Well, we're doing good. So the algorithm of a code is basically it's a sequential steps English level. There's no coding right here. You break the steps down to smaller steps with it as well. So each one of these steps that you break down to smaller steps with it, it goes in detail whatever the steps it does. And each step needs it to build onto the next steps with it. So you could have a process, think of a subway line. I mean, how did you get to a complete sandwich at the end of the line? What was asked for from you in the middle of the line? So as your sandwich evolves in each one of these steps, one step build off of another one with it. Remember now, you can't come into the middle of the beginning of the sandwich and tell the person at the beginning that you want certain type of greens like lettuce, black olives, or a certain type of dressing. It doesn't apply at the beginning of the line. It has to fit somewhere after the meat or the toasting of the sandwich and all that stuff. That's algorithm. You're writing the steps to break that down to smaller steps with it. So we'll talk more about this as to apply to the process with it. And then you take that algorithm, that pseudocode, flowchart, all of that, you take it to the code of the program with it. And that's how you write the code with it. Now, there's a lot of, the purpose of the compiler is to take this higher level language that you're writing in C++, and then it permits you to actually going down to the machine level and writes it to the machine language, which is lower level machine level programming code. That's the purpose of the compiler with it as well. All right. You test it all the time. You always, you go back, you test it, see if you can break your code with it. You will hear programs will exist in program cycles as alpha, beta. Software development is always a beta version. So software will always evolve as we develop the software with it. I want to stop right now. This concludes the first part of Farrell of Chapter 1A. So stay tuned for the second part, okay?